In this video, we're going to look at some of the basic terms of motion. We're going to talk about distance and displacement. I'll also talk about speed and velocity, as well as meters per second as opposed to kilometers per hour, and how to transfer between the two. So firstly, distance. Now, distance is a measure of how far an object is from the start point, or where it was before. And this is something that you're quite familiar with. When you go for a drive in the car, you might start at one point and end up a distance of 10 kilometers away, for example. Distance is measured in meters, and the symbol for distance is D. Displacement is similar to distance, only rather than distance being how far you've traveled, displacement is how far you are from your starting point. So that's as the crow flies, how far you are from the starting point, as well as having a direction. So in this, and it's also measured in meters, and the symbol for displacement is S. So in this example, you can see that the distance is the blue line. So that was the path taken by whatever object it was. And you can see that the distance, because they didn't travel in a straight line, is much longer than the displacement, where the displacement would be a much shorter amount of meters, and in the direction southeast. Sometimes we don't have a north, south, east, west direction. Sometimes we define a direction in two dimensions, and then we can just talk about the displacement as being either positive or negative. So for example, if I draw a straight line and say if I move in this direction, it's positive and the other direction is negative, if I move in that first direction, I could have a displacement of 3 meters, while if I move in the opposite direction, I'd have a displacement of minus 3 meters. So that positive or negative is the direction that you're traveling in. Speed is related to distance, and it's the rate at which distance changes in a given time. And in science, we measure speed in meters per second. You also might see it in kilometers per hour, for example, in cars and things like that, and less so in Australia in miles per hour. And the symbol for speed is V, and that's because of its relationship with velocity, which we're about to talk about. And the formula to find a speed is speed equals distance divided by time. So velocity is related to speed, but rather than going off the distance changed, it's going off the change in displacement. It's again measured in meters per second and also uses the symbol V. So in this case, velocity equals displacement divided by time. As I said before, we usually use in science meters per second. However, if you're in a car or something like that, it might be measured in kilometers per hour. So we need to be able to change between kilometers per hour and meters per second. So kilometers per hour just means that in 1 hour we travel 1 kilometer, or 1 kilometer divided by 1 hour. Now, to get from this kilometers per hour to meters per second, we need to know a few of the numbers to change into, and that's 1 kilometer is 1,000 meters, and there's 60 minutes in 1 hour and 60 seconds in 1 minute. So they're important for us to convert. So we have 1,000 meters in 1 kilometer, 60 minutes in 1 hour, so we can rewrite 1 kilometer divided by 1 hour as 1,000 meters divided by 60 minutes, because it's exactly the same thing. We can go one step further than that to say that yes, we've got 60 minutes, but there's 60 seconds in each of those minutes. So therefore, 1,000 meters divided by 60 seconds. And if you work out 60 by 60, there's 3,600 seconds, which, if you condense it down, comes down to 1 divided by 3.6 meters per second. So if I take that up then to the original kilometers per hour that we had, where 1 kilometer per hour equals 1 divided by 3.6 meters per second, and times both of those sides by 3.6, we end up with 3.6 kilometers per hour equals 1 meter per second. Now, some people like to actually plug it in and do all these calculations and convert meters per second, convert to the minutes, convert to the seconds, all that sort of thing. Some people just like to remember the number 3.6 and use that number 3.6. And the easy way to remember it is that there's 3.6 kilometers in 1 meter per second, so it's a bigger number in kilometers per hour than it is in meters per second. And kilometers are bigger than meters. So if you want to go from meters per second into something bigger, you times it to make it bigger. So an example of using this formula would be if we had 20 meters per second and we wanted to turn it into kilometers per hour. All we'd do is take our 20 meters per second and times it by 3.6 to make it bigger, and that will give us 72 kilometers per hour. And we can do the same thing in the opposite direction. And so we've got 100 kilometers per hour, and we want to find it in meters per second. So we want to make it so from kilometers to meters, which are smaller. So in this case, we divide by 3.6, and we end up with 27.7 repeating meters per second. So it's quite easy to move from kilometers per hour to meters per second. You just need to remember the magic number of 3.6, and remember that when you're going from meters to kilometers, you're increasing because the kilometers are bigger. In this video, we have looked at distance as a measure of how far you have traveled from the starting point, displacement, how far your final position is from the starting point and in what direction. We've looked at speed, being how quickly you've covered that distance, and velocity in how quickly your displacement has changed. We've also looked at some of the common units of speed and velocity, meters per second and kilometers per hour, and how to move between the two.